my friends, welcome to my channel focusing FreeCAD. Today I want to work on the assembly workbench, the new assembly workbench on FreeCAD 1.0 version. This is the RC2, this is the release candidate 2 version. Alright, at this moment before I actually get into this video, I want to address two quick points. Look at that. We have only two open bugs that's preventing this release of FreeCAD 1 version. So where it says blocker, this is what blocking there. So only two. It has been like 8, 9 for some time, but so we are inching towards the FreeCAD 1 version pretty soon. I'm very excited about it. So I want to thank the developers working for towards this release. The second issue I want to talk about is on sale. In several past videos, I have been working with on sale, and then on sale lens, I have been uploading my models in there for you all to take a look at them and download them. So that was a great idea. And recently, like 1 day ago, OnSale says they are shutting down their operation and they are like closing for good, but they will be contributing everything to the FreeCAD version that we are all working on. So I want to thank OnSale for their work. Out of all the contributions, the most important to me is that the development of this assembly workbench. So OnSale put in a lot of work in this, and which is great, and also they have done a lot of remarkable other works as well. So take a look at their contribution in their blog, but I want to thank them for their contribution in this community. All right, with that two things out of our way, let's talk about what I'm going to do today. So in the new assembly workbench, I think they have more things to add here, but with all of the simple but yet very effective tools, one thing I was missing is so here we have a slider joint, right? So this slider joint lets like members go up and down in a slot, but it's mostly for circular profiles. What if we wanted to have a sliding circular like cylinder in this slotted area? And there is no tool for that right now, and I will explain a little bit more, but today I want to work around in that absence and then see how we can work. So I came up with this idea how to make a slot sliding, and let's work on that one. Let's create a new file and then let's explain what I was going to say. So I am going to create a cylinder and then another tube. So I have one cylinder, another tube, and I want to say, let's hide these two and go to assembly workbench, create an assembly, and I want to add that tube first. That's my base fixed there. And then let's add this cylinder. Now if I apply this slider joint, right, so I want to apply that in this here, and now we can take this tube up and down. It's like a cylinder, like a piston. So now it is working as a piston. So this is now moving up and down. That's what the slider joint does. So but one limitation is that it is looking for a circular profile. What if we had, so that is one example, right? Very simple, very easy. It is, it will be really easy to apply in multiple places. But what if we had, say, I'll quickly build a model. And I'm going to go ahead and extrude that in a symmetric fashion. So we have these, that's our, I'm going to say that is our slot, right? This is our fixed base, that's our slot. We want to have a cylinder, well, not a tube, a cylinder in the middle, And now I think I'll have to actually specify the dimension. Just so that's a 5 millimeter radius, and let's create this cylinder 5 millimeter as well, and then put a height, say 50 for now, and I want to go ahead and quickly lay it down. So there it is. Now say I wanted to have this cylinder sliding up and down, or rather left and right. So in the assembly workbench, I wanted to have, say, this cylinder moving left and right just like that. How would you do that? With these current tools available in assembly workbench, I did not find a tool to allow that kind of movement in this slot. So which is also, it is a very practical example. Like it is more often than not that we will come up with this application, and currently the assembly workbench does not address that. So I was thinking about this workaround and how actually we can allow this kind of movement. So let's go ahead and work on a model and see how we can address this feature. So let's start with a new model. I want to model this on XZ plane and quickly create a slot. Let's say this is a vertical slot. Okay, so we have our base sketch, and now I want to extrude that for, say, 30 millimeter, just like that. And now I want to make a cut in the middle right here, and I will do that through another sketch. So I want to do it as a common or intersection between these two. Actually, now that I see, let's make this symmetric, right? And now let's work on this sketch that I want to make it a common area. So it will be a similar sketch. Maybe what I can do is I can copy this sketch. So take this one, and it says in the bottom, it says hold Control Alt to allow non-parallel. So Control Alt and then, all right, there it is. So it was easy to copy that same sketch, and it's fully constrained. And I see that there are some overlap, like that's not enough of the extrusion. So maybe let's get into there, see what this distance is. So that is 40 millimeter. So we'll have to make this extrusion 40. And now it is kind of covering. Actually make it 42 maybe. So there will be some overlap. And now I want to extrude this one for 42 millimeter in symmetric fashion. So now we have these two. What we can do is we can take these two and make a common intersection, and we have this contraption. That was easy. So we have a slot in here and another slot in here. What I'm thinking, a bar will go through in the middle, and another one will be for that pivot hole to go through. All right, and let me make that horizontal bar that I showed in here. So this horizontal bar, and I want to do that through another sketch. So get to part, draw on XZ plane. All right, so we have that rudimentary sketch done. I want to extrude that to fill in this gap. Yes. So we have that now going up and down. I think we have almost everything that we need. So we'll have to come up with a support here and a hole right there to hang it. First of all, I want to work on this one just for a little bit more. So XZ, right here I want to make arrangement for this very simple support, right? Now I can extrude that for 20 millimeter, symmetric, apply, close. Then I want to make that 2, I'm gonna say connect will do, yes. So that way there is this allocation for the support. Now I want to work on the support. The support will be, I want to make this easy. So what I'll do is I'll just draw 2 circles of say 10 millimeter in here, one and another one on the same sketch. So that way you will be spending less time configuring it later on. Right, so they're like in place where they should be. So it would be easy for me to actually work on them later on. So let's make it 20. Maybe make it symmetric and hit apply, close there. So I have that support in there. It's right there. It's there. There's one support and there is another one, but they come from the same sketch. Should not be a problem. Now, so that's our arrangement for everything. Now let's talk about how we can apply that principle that we were talking about. Actually, now that I'm thinking about, I can actually make this part a little bigger. So let's do that. Not that it matters, but I want to do that. Now it looks better. All right, so our original plan was to have a cylinder. This cylinder, so let's lay it down just like that. And let's make that 10. And height wise it would be 20. And let's see, on the position, I want to say this is minus height over 2. Hit OK. And oh, I did the wrong thing. So it will be on Y. So it will be on Y. That will be minus height over 2. It will be plus. I should have thought it through, but there. So now it's in the center, right? And maybe make it a little bit more high. So there. So our original plan was to have this. This is the slot. This is the slotted area. And we want this cylinder to go up and down in that slot. And we established the fact that we cannot do this slider option in there. So in here we have this slider. There, create a slider joint. We established that it doesn't work like that. So what I'm thinking, there is a parallel plane. Create a parallel joint. I think I can use that one effectively. So let's explore that. To make this plane parallel with this one, we need a parallel plane. So what if I thought like this? What if I created a rectangular face on top of this cylindrical, like circular face? What if I created a rectangular face like that? So it would be 20 on this side, 20 on the other. And then say I extruded that for 10 millimeter, but in the reverse side. So it's right there. So in there is the cylinder, but at the end it has a square face, right? Let's do that for on the other side too. So I want to mirror it over on the other side. Now I can take these 3 and put them together. So instead of having a cylinder like that, now we have a modified end cylinder. So cylinder with modified ends. All right, so now we have this horizontal bar fitted with that modified and cylindrical pivot. Now let's see if you can move it up and down. So I want to rename everything accordingly. So this is going to be, say, pendulum. And this is going to be support system. So support in short. And this is the pivot. And what else? This one. That's the horizontal bar. Okay, pretty basic. Now I want to hide everything. Let's go to assembly and create an assembly. So I want to start with, all right, I have too many files open. So I want to start with the support system there. Now I have this default setting where the first thing I add becomes grounded. So it is grounded. You can take a look at it by looking at this lock. So that's grounded, right? Now let's add the pendulum there. I want to go ahead and take care of this pendulum. So it will be a revolve in the middle there. So because these are all created in place, I don't have to adjust anything. They just fit in right there. So now I have this one kind of moving up and down. Right. Now just to get it out there, I know that I spent very little time modeling this part. So if you have any question on how to model this, just let me know. I will explain it in a later video then. All right, let's keep adding. I want to add this horizontal bar in there and do the same thing. Use this revolute joint because it's just like a bearing. It just revolutes. There is no horizontal or like in a vertical movement allowing there. It's just a rotational movement. So now it's moving up and down. This one is moving left and right. So we have two pendulums, one vertical pendulum, another one horizontal bar there. So you can see that just keeping this one fixed in place doesn't work because every time this goes up and down, it's a circular area. So if it comes down here, this will have to move just like that. If it comes in the middle, it will have to move like that. So it has to be a flexible joint. Right, now let's go ahead and add our pivot, which is the main part there. And I'm going to go ahead and hide this one for a minute. And maybe, so in this, I can grab this and make it there. So this is going to be another revolute joint because this face will always be vertical. Now this will go up and down. And so there will be some movement in there and I don't want to fix it in place. These two faces, I don't want to fix them. I want to actually make them a revolute. Just like that. So the easiest way, because this width is equal to this width, we can match the center. So take the revolute joint and select it right here so that the axis cross comes in the middle. We can select it in the end too, or like that end, but on this application I want to select it in the middle and also do this here in the middle. Right, that's the end and it's the middle, it's on this end. So take it in the middle so that way it kind of like snaps into place there. So now this is rotating in there and we will be needing that movement. All right, so we have everything. Now it is time to put the different parts, key them in together. For now, everything is moving on their own. So it's time to put them together. What I want to start with, so this is the new thing, this distance joint, parallel joint, and perpendicular joint. These are the new addition to this assembly workbench. So let's apply some perpendicular joint between these two, and in my mind that should be enough. Like this this parallel joint we just applied, it should be enough. So we'll see if that is enough. Otherwise, we'll just come back and then apply another parallel joint with this face in here too. We can do that later on. But for now, there is that. And then I want to make it right along. So take these two faces and make it a distance joint of 0. And that should work. So moment of truth, fingers crossed, it is working. So as you can see, this is moving up and down, and then the slot, this slotted area is allocating movement, and although it is very minimum, you can see this rotation, this movement here. This bar, look at this bar at the downside. It is going to right, going to the left as it comes to the middle, and then again it goes back to the right. And that movement kind of allows this horizontal bar to go up and down. So although we don't have a slider joint that allocates this slotted movement, we can use a couple other tools in our shed to actually build that joint. We can fine tune this. So because this is a rectangular area that's sliding up and down, I don't think it will go further than this and come down further than this. We can limit that movement. So if I move it, we can see that there is an axis cross appears, means that's the active point. So expand that one. This is the grounded joint showing visible. Let's hide that. Now move it. We can see that Revolute 001 on the left panel is the active one for this. We can go to there and take it all the way up. Look at this value. It says minimum angle minus 17.83 on both of those, and bring it down, and this value reads 18.0. So one of them is 18, another one is minus 18. So what I want to do is I want to start with the minimum one. So, or maybe other, let's go. So make it minimum and select that, right? And then bring it down and select that. Now we can go ahead and make them rounded up or down. So minus 18 and plus 18. Let's see if that works. Now we should limit. So we are not going any more up there. That's the limit we want to be in. All right. I think our experiment worked fine. And also I have seen, like, when there are like multiple joints acting together in this assembly workbench, sometimes the software kind of lags, goes a little slow, but this one is handling pretty good. And I think this principle we will be using in future videos as well. So if you have any question on this, or like if you know a better way to do that, please let me know in the comment section below. In one of my next videos, I want to use this principle in developing another model. As you can see here, this mechanical movements 101. This one shows a similar idea where we have a slotted joint. In the middle, there is this cylindrical shape that goes that allocates this movement in that slot. And in the animation, it shows that this principle can be used to build this plunger kind of thing that moves left and right. So maybe we can use the method that we just described here. We can use this method to build that plunger, that movement that we just saw on that website. Instead of making this fixed end, we can allocate it on the left and right. So in the next video, maybe I will try to develop this movement. So keep an eye out for that one. And again, if you have any question, comment, or suggestion for this, let me know in the comment section below. Thank you for watching. I will see you next time.